On the atomic scale, we think in terms of electron volts because we know what volts are like. 13.6 volts is something we can really relate to. It's just a little more than the voltage produced by a 12-volt battery. If we had a capacitor charged up so that there's a 1-volt potential difference between the plates, we could take an electron, a free electron, with velocity 0 at the negative plates and release it, and it would accelerate over to the positive plates. It would move over there very fast, actually. The kinetic energy of the electron here at velocity 0 is 0. The energy it gains, if there's no impediment to its motion here, just if it's moving freely under the influence of the constant electric field between the plates of the capacitor, will be 1 electron volt, because it's an electron that's gone through a potential difference of 1 volt. It's a charge of 1.6 times 10 to the negative 19th coulombs, which has gone through a potential difference of 1 volt or 1 joule per coulomb. It therefore has a kinetic energy equal to 1 electron volt or 1.6 times 10 to the negative 19th coulombs. Now the figure we have here is a schematic. We're going to say that the n equals 1 electron, when n equals 1, the total energy is negative 13.6 electron volts, as we saw before. This is the 1 over n squared times negative 13.6 electron volts. So the n equals 1. If n equals 1, 1 over n squared is 1 times negative 13.6 electron volts, just gives us the negative 13.6 electron volt potential. We're going to illustrate that. We're going to put that right here. And we're going to let energy move along the vertical or the y direction, if you prefer. We're going to put total energy 0 here, total energy negative 13.6 electron volts here. Okay, now if n equals 2, then the energy is 1 over n squared times negative 13.6 electron volts. 1 over 2 squared is 1/4. 1/4 of 13.6 turns out to be 3.4. So this is an energy of negative 3.4 electron volts, and that's the energy we get when n equals 2. Remember, between n equals 1 and n equals 2, the radius goes from 0.529 angstroms, a nice tight little circle, to 4 times that, to n squared, or 4 times the 0.529 angstroms. The potential energy, therefore, increases considerably, and the kinetic energy decreases. But the increase in potential energy is greater than the decrease in kinetic, and we end up with an increase in energy from negative 13.6 to negative 3.4 electron volts. So to go from 1 to 2, we have to increase the energy of the electron from negative 13.6 to negative 3.4 electron volts. That would be an increase of about 10.2 electron volts. If we wanted to go from n equals 2 to n equals 3, we would have to move even further out into the n equals 3 orbit at 3 squared, or 9 times the 0.529 angstrom distance. The kinetic energy would decrease because of the slowing of the electron as it moves out. But we would end up with a total energy of negative 1.5 electron volts. We get that total energy by doing the 1 over n squared times the negative 13.6 electron volts. N squared is 9. 1/9 of 13.6 is about 1.5. If we wanted to go from n equals 2 to n equals 3, then we would have to add 1.9 electron volts of energy. We could go to n equals 4, 5, 6, 7, 8, 9, 10, whatever n is. We're going to multiply the reciprocal of its square by the negative 13.6 electron volts, and the energy is always going to be negative, although as n gets larger and larger, the energy gets tinier and tinier. The energy approaches 0 but remains negative. So n equals 4, n equals 5, n equals 6, all the way up, all the way approaching infinity. All of these n values will have energies between here and 0, between the negative 1.5 electron volts and 0. Okay, another thing that I'll mention is that if an electron is in the n equals 3 state, it will spontaneously fall into the n equals 2 or n equals 1 state, and rather quickly, as a matter of fact. Okay, if we fall from the n equals 3 to the n equals 2 state, we are going to lose 1.9 electron volts, which will be carried off by a photon. The photon will contribute to light coming out of this, say, a discharge tube, and that light will have a wavelength, again, that's related by the E equals HF relationship. So that if we have this 1.9 electron volt drop, photon with 1.9 electron volts will give light of a very specific frequency and wavelength. And it turns out that if we go from n equals 3 to n equals 2, that light turns out to be visible. If we drop from n equals 3 to n equals 1, that's a lot of energy, and that light is so energetic that it's ultraviolet. It's not visible to the naked eye, although we can certainly detect it with ultraviolet film and other devices. Turns out that anything that falls to the n equals 1 orbit, even from n equals 2 to n equals 1, has too much energy to be visible. It's ultraviolet. Anything that falls from a higher level down to n equals 2 will be visible. Okay, even from n equals 0 to n equals 2, from n equals infinity to n equals 2 will give us visible light. Anything that falls to n equals 3 won't have enough energy to be visible, and it'll be ultraviolet. I'm sorry, infrared. Too little energy, longer wavelength, infrared. In any case, these are some things that you can tell from this diagram.